Right, so today we're going to be solving a related rates problem, which is a topic in AP Calc BC. So the problem we have here is a cone cup is 4 centimeters across and 6 centimeters deep. Water leaks out at a rate of 2 centimeters cubed per second. How fast is the water level dropping when the height of the water is 3 centimeters? So I like to go ahead and start off with drawing a picture of my given information. So we have a cone here, and then we know it's 4 centimeters across. And if it's 4 centimeters across, that's the diameter. So really our radius is 2 centimeters. 6 centimeters deep, and then water leaks out at a rate of 2 centimeters cubed per second. Now notice how this is a rate, it's not just a value. And then how fast is the water level dropping when the height of the water is 3 centimeters. So they have given us at a certain point in time, the height of the water is 3 centimeters. Notice how the height is a constantly changing value. It's not a fixed value, such as the height of the actual cone cup, which is 6 centimeters. That never changes. The height of the water, however, changes each second. So this is a constantly changing value. It's a variable. So our first step was drawing a label for the problem. Second step is writing down what we know and what we want to find. So we know the height is 3 centimeters. And we want to find how fast is the water level dropping. So really, the rate at which the height is changing. And we always want to differentiate with respect to time. So height, the derivative of the height over the derivative of the time, that's really the rate at which the water level is dropping. So this is going to be our unknown, what we want to find out. And then we have our volume. So how fast is the water level dropping? And then we have our volume formula, which I want to write here as V equals 1/3 pi r squared times h. That's the volume of a cone. And now you see in the volume formula we have 3 variables. We have our volume, radius, and height. However, we can only solve for 2 variables at once. So that means we need to rewrite this equation and write one variable in terms of the other. So we can do that with radius and height. So we know that our radius is 2 and our height is 6. Now we can set up a proportion. And since we want to find the height, that means we want to rewrite our equation of r in terms of the height. So we can write 6r equals 2 times the height from the given information here. Then we can rewrite it as r equals 1/3 times the height. And if you plug in 6 for the height, we get a radius of 2. So we know this is correct. Now we can substitute this r value in our equation. So our equation is only in terms of volume and height, which is what we want. Now, how do we know what to rewrite? Well, we know we want to find the height, so that means we need to change the radius. That's how we knew that we had to rewrite the radius in terms of the height. So now we can rewrite our equation in terms of 2 variables. So we have V equals 1/3 pi r squared. So if r is 1/3 height, then r squared will just be this squared. So 1/3 height squared, which will be 1/9 times h squared. So we can just substitute that in there, times h. So now we can rewrite that as 1/27 pi h cubed. Okay, so this is our equation. So now that we have our equation in terms of 2 variables, our third step will be to differentiate in terms of t. So everything that we differentiate, we want to make it over t. So we have dv over dt equals 1 over 27, sorry, that's 1 over 27 pi times h squared. And now notice we need to add a 3 in front using our differentiating rules. So we added that 3 in front and then put our height in terms of squared, and then finally it's dh over dt because that's what we're differentiating. Now we can simplify this up. So dv over dt equals 1 over 9 pi h squared times dh over dt. Now this is the part where what you've written down really helps. So we know our height is 3, that means we can substitute that in. And we also know that the water is leaking out at a rate of 2 centimeters cubed per second. Now this actually represents that dv over dt, that rate at which the water leaks out. So we can actually substitute all these values in. Now, I just want to remind everyone that we always substitute the values after we differentiate, especially these variables. Only substitute after we differentiate. If your equation is in terms of a constant, for example, if we had like a rectangle and we had length, which remains a constant, then we can plug that in before. But for the constantly changing variables, such as height, which changes every second, height of the water, we want to plug that in after we differentiate. So dv over dt we said was 2, 1 over 9 pi, and then the height of the water was given as 3. So we have 3 squared times dh over dt. Now this is the correct equation because we know we're solving for dh over dt. How fast is the water level dropping? That's the rate at which the water level drops. So that's really the rate at which the height of the water changes. So that's what we're solving for here. And now that we don't have any other variables, we know that we can solve for that. So 2 equals 1 over 9 pi times 9 times dh over dt. 2 equals, we can cancel that out, pi dh over dt. And then our dh over dt is going to be, so we can simplify dh over dt, that's going to be 2 over pi. And now here, we have our 2 over pi, but that's not our final answer. We need to put that in context, which means we need to add units. Now remember this dh over dt, this always represents a rate. In this case, the rate at which the water level drops, which can also be rewritten as the rate at which the height of the water changes each second. Now remember, it's always over time. So our final answer is going to be 2 over pi, and then that's going to be centimeters over second, because since we're doing a height, that means it needs to be centimeters over second. So that is our final answer. Now just a quick recap of what we did. So we really just followed the steps for using implicit differentiation. So first we do a picture of our information that was provided. And then we wrote our givens and our unknowns. So we knew our height was 3 centimeters, the height of the water at a given point in time. We know the radius is 2, the height of the cone itself is 6, and the rate at which water leaks out, that's going to be 2 centimeters cubed per second. And how did we know that was the dv over dt? Well, that was because it's 2 centimeters cubed over second, so that represents a change in volume over time. So we know that we could plug that in after. Now we want to solve for dh over dt because the question is asking how fast is the water level dropping. So that's going to be the height of the water. And then, since we have our r equals 2 and h equals 6, we can rewrite radius in terms of the height. So we have r squared equals 1/9 h squared. Now, how did we know that we need to rewrite the radius? Well, we know that the only two variables that we want in our equation are the volume and the height of the water. So we know that radius, that needs to be in terms of the height. So always make sure to rewrite your equation if there's more than two variables, and be sure to know which variable you're rewriting. In this case, that was the radius. And then our last step was going to be to write that equation, rewrite it so there's only two variables, differentiate it, and then after you differentiate, you want to sub in your given values. And then you just have to solve for that rate that you're finding. In this case, that was dH over dt, how fast the water level is dropping. And lastly, when you have that, you just want to rewrite it in units. So you can either leave it as 2 over pi, or you can put it as 0.637 centimeters over a second. Same thing. So that's all for related rates.